All right, so probability tree question. We'll read it first, okay? So it goes, there are 10 prefects in the school. 4 of the prefects are vegetarian. 2 of the prefects are chosen at random to have lunch with a visitor. Show that the probability that they're both vegetarian is 2 over 15, okay? So remember my kind of like, I don't know, what do I say, like my thing? Virtually every probability question is usually a probability tree question. So this, by the way, is actually similar to like bags and a ball kind of stuff. So here's how you got to think of it, you know. Altogether, there are 10 prefects, yeah? So you got 10 altogether. So the amount who are vegetarian of these is 4, and the ones who aren't is 6. Do you see how it's that? And they're just going to be 2 picked at random. So it's a reasonably straightforward probability tree, but it's a tough question, like kind of the way it's hidden. So, you know, now we got to first consider the first prefect. So first prefect. Okay, can you see the probability is vegetarian is 4 over 10, and probably is not is 6 over 10. That's the first one done. Then we've got to consider vegetarian, not vegetarian, vegetarian, not vegetarian. Well, now remember here things are changed. So remember, one prefect has been picked now. One prefect's been picked. Let me actually do that bottle here. This is if first is veg. So now, obviously, look, one guy's been picked, so now there's only 9. So can you see, because one vegetarian's gone from like what was here, there's only actually 3 left. And the amount of who are, you know, non-vegetarians are still 6. So here, this is actually going to be 3 over 9. 6 over 9. Now, funny enough, you might be tempted to finish this bit off and consider what, you know, the makeup would be if they had picked like a non-vegetarian. I mean, I'm going to show you. I'll show you for the sake of showing you. But can you see, you don't actually need it. You don't actually need to do it. Because the question says, show that the probability are both vegetarian. So really, all you need, do you remember this, if I, let me get the red out. If I got this, oh my lord. Yeah, if I got this path, the vegetarian path, well, that's what my question is asking me for. Show that both the vegetarian. This is the vegetarian one. So I would do this by doing 4 over 10 times 3 over 9, which will gives me 12 over 90, which cancels if I divide top and bottom by 2, will give me 6 over 45. And then if I divide top and bottom by 3, I get 2 over 15. So my question's actually finished. So I don't actually need, really, you don't have to do the whole probability tree if you don't want to. Just see what the question's asking you. But I'll do this one quickly anyway, just for the sake of, if you still feel in any way unsure of, ooh, well, how would I finish these off? So this is more just kind of like a show you thing. So okay, here's how we started off. Remember, when we go down this path, when we get to this not vegetarian, it's basically saying that give me a second, you guys calling me. Forget it. It's saying that, look, a non-vegetarian was taken out of this box. So now obviously 9 are left because one guy's gone. Well, the vegetarians are still the same. That's 4. And there's 1 less non-vegetarian. Alright, so the probability here would be 4 over 9. That'd be 5 over 9. And you'd have to do that, for example, if you want to find out the probability of like 2 of them were non-vegetarian, or 1 was vegetarian, 1 wasn't vegetarian, etc., etc. But hopefully that makes sense. Remember, it should be focusing on how these probability trees are made. And then really, you know, every probability tree just kind of gets to the point of, you know, it's only, there's got 4 paths. First, vegetarian, 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 not vegetarian, not vegetarian, vegetarian, not vegetarian, not vegetarian. And then you just have to look at the question and say, okay, which one of these do I want? In this example, it was just the vegetarian. So you just kind of multiply up those paths and actually answer. But sometimes you might need more than one of these. For example, if it said the probability that one's a vegetarian, one's not. So that could be this one and this one. So you'd have to find the probability along these 2 and then these 2 and add them together. Okay? So hopefully that serves as a quick refresher.